Well, hello, class. How's it going? Today we're going to be talking about energy and the different types of energies that there are. Currently, my projector is being a little weird. As you can see, my smartboard is just a normal smartboard. So we're going to do this the old-fashioned way with books. Now, I happen to have a book right here. Let's dig into it. All right. So it's about energy. It says there are energy is divided into two forms. There's kinetic energy and there's potential energy. Now, kinetic energy is the energy of moving things, while potential energy is energy that is stored. And you know what I'm saying? I'm seeing a lot of little sleepy pants out there. So why don't we put this book away for a second and let's go kind of explore and just look for some types of energies out there. Does that sound good with you guys? All right, good. So why don't you just follow me over. Let's go. There's bound to be some things in my storage room to help us out. So let's head on there. All right, you ready? All right, let's do this. Now, my back closet, as some of you might have guessed, is very spacious. It's very nice back here. So let's just go look, see what we can find. All right. So this is the first form of energy that I come across. I don't know what that means though. Key mech. Let's look in the book. Alright. Types of energy that are kinetic include mechanical, electrical, sound, light, and thermal. Alright. Oh, mechanical energy. Hey, that's what I just saw. This type of energy is kinetic and it's the energy of motion. If you can see it moving, then it must be mechanical. Okay, so here I can see my cow on a railroad cart just moving in circles. Clearly I can see him moving, so that's got to be some form of mechanical energy there. Also, these pistons are a good example because I can see them move. They have mechanical energy as well. If I stand in the middle and I get shoved back and forth, then I will have mechanical energy as well. This brings us to the second type, electric. I think I saw that in the book too. Let's look at that. It says electrical energy, also known as electromagnetic. This form of kinetic energy deals with moving electrons. Alright, so an example that we see in Minecraft is redstone. Redstone is very similar to wiring that we see in the real world. Whenever it lights up in Minecraft, it means the circuit is flowing through. We can't actually see this in the real world, but in Minecraft, this is a good example of seeing the movement of the electrons or of the redstone as it powers things like my piston machine over there. Alright, let's move on to this cool little sound booth dealy. Alright, so it says that sound. Okay, well let me read the book. See what that has to say about sound. Alright, it says this type of kinetic energy deals with vibrations in the airwaves that allow us to hear things. Okay, so let's go listen in on what's going on here. This is the Old MacDonald gang. They tried to rob a farmhouse the other day. And let's see what they're trying to say. What do you got to say for yourselves? Really? You don't listen to their honey words. They are guilty, each and every one of them. Alright, let's move on. Oh, look, a door. And look at the time. It is really gotten dark. But luckily these torches are here. We can just follow the torches. It'd be very hard to see otherwise. Oh, speaking of see, that brings us to number 4. Let's look that up as well. Alright, number 4, there's light. Mechanical, electrical, sound, light. Also called radiant energy. This type of kinetic energy includes visible light and other waves such as microwaves and radio waves. Okay, cool. So not just things that I can see, but things that make my microwave work or allow me to hear the radio, things like that. Okay, let's do a super jump. And here I am. Oh, this is a neat space. Alright, thermal. Let's look that one up. Number 5 is the last one on my kinetic energy list. Thermal energy, sometimes called heat energy. This type of kinetic energy deals with temperature changes, both hot and cold. Okay. Well, what's in this box, I wonder? Oh, that's cool. Some fire charging, some flint and steel. So, clearly, we are meant to find an example of thermal energy. Look at that. This is clearly what you should do in a forest. And now we can see a good example of thermal energy. We can see the fire that comes from it. It's heat. The temperature changing is getting a bit warm here, and that is really getting away from me. I did not mean to start such. I thought it'd be like that one, but oh well, shoot, that's getting off the ground too. Whoa, we better get out of here. Let me put that away. I Yikes. Let's just let's go over here and run away from that. All right, let's go into here. And you probably don't know what this means right here, but I certainly do. It means we're entering potential zone. And oh look, more fire. Let's read about this for a second. Potential energy chemical. All right, so we've done mechanical. That's all mechanical. Or let's see, thermal. All right, potential. So we just finished our kinetic section, and let's look at potential. It says there are 4 types: chemical, gravitational, elastic, and nuclear. So chemical energy. This type of potential energy is stored in foods, chemicals, wood, and batteries, just to name a few. Okay, so I have some examples here. A Minecraft example would be netherrock, because this will burn indefinitely once you light it. So right now it has potential chemical energy because it has the potential to burn. Once I light it, and it will just go on for a long time. Lots of other chemicals in the Minecraft world, we call these potions, but in the real world, things like acids and vinegar and baking powder and baking soda and Mentos and Coke and all those things like that that combine to form reactions. Also, fireworks is not a bad example. They all have potential chemical energy. Food as well. If you are hungry and want some cake, you can just get that here. Let me put that out so I don't burn anything else. And wood as well. So that wood burned so well because it had a bunch of chemical energy in it. Now, speaking of trees, I am actually a very good tree climber, and look at me go. I am a very quick tree climber, actually. And no, that is an excessive amount of burning over there. Let's just continue with our climbing of the tree. I bet that when we get up here, we will be able to see the sunrise. Oh, look at that. I was correct. Oh, here on the top. Well, look at this. Number 2, potential gravitational. Let's have a look in the book, see what that says. Alright, gravitational energy. This type of potential energy increases the higher you get off the ground and is equal to your mass times the gravitation times the height. Alright, so right now I must have a lot of gravitational energy in me because I am the highest that I can stand on Minecraft. So this is really pretty cool. Now, if let's say I were to jump off or something, then I would start to I would start to convert all of my potential to elastic or to kinetic. That's gonna hurt. Ow, ow, that's a sprain. Right, so as I was plummeting, I couldn't think straight, but all my potential gravitational was transformed into kinetic mechanical as I fell. Alright, that brings us to another one. Looks like elastic. Let me look at that up in the book. Elastic energy. This type of potential energy is seen when objects are compressed or stretched and want to return to their original position. Okay. Oh, what's in this box? Oh, look, a bow. That's kind of cool. Let's take that. Oh, a hay bale. Oh, and a lot of fire. It'll burn out. Don't worry about it. Alright, so I'm calling this now dead center in this hay bale. It's got nothing on me. Bam. See that? That's pretty good. Maybe a little low. I'll give one more shot. So as you can see, as I've pulled back the bow, it is stretched and it wants to return the position. You can see it on the right hand side of my screen. When I let go of the mouse, it transforms all of my stored elastic energy into mechanical and shoots it down the range. Let's just put those back, and I'll leave those in there for victory's sake. Oh, that's a weird thing to have right there. Okay, well, a shrink chamber. That seems exciting and useful. Let's go in there. What to say? Press button to begin shrinking. Okay. Oh dear, what's going on? What's going on? What's going on? Oh. Oh. Oh, I have shrunk down and I have landed on top of an atom. Wow, you do not see that happen every day. Oh, these must be the electrons whizzing around. Oh, and the protons and the neutrons. Yes, there really are blue and red, just like I was taught in 6th grade. That is cool. Alright, well, let me look this up. See what my book says about this. We should be towards the end. Yep, the last one on my list for potential. Okay, nuclear energy. Says this type of potential energy is the energy that is stored inside of an atom. Hmm, that is cool. But it doesn't say what exactly it is. It's just inside of it. I wonder, maybe I wonder if I could get into it. What would happen? Can't really. Oh, I got some flint here. Let's see what happens if I try and just crack this open just a little bit. Let me just crack just a little bit of this open. See what. Oh, oh dear. Should I have done that? Should I have done that? Should I have done that? Oh, it was all just a dream. Maybe. Oh, well, now. Either way, we are safely back in the classroom. That was that was rough for a second there. I thought we were being in real trouble. Anyway, thank you for coming to school today and learning all about energy. And if you would please, pick up all your trash on the way out and have a good day.